Now let's discuss about metric used in EIGRP. Actually, EIGRP uses a composite metric, and this is composite matrix is combination of 5 different things. These 5 things are, are called as key values. So it means EIGRP uses 5 key values as a matrix. What are these key values? K1, K2, K3, K4 and K5. K1 is bandwidth. The K2 is load. K3 is delay. K4 is reliability. And K5 is MTU. MTU is maximum transmission unit. It is a value that defines what is the maximum unit a router or an interface of a router can send over the internet. This is MTU. So in EIGRP, the metric is combination of these 5 things, that is bandwidth, load, delay, reliability and MTU. It shows as K1 as bandwidth, K2 as load, K3 as delay, K4 as reliability and K5 as MTU. By default, EIGRP uses 2 things. The first one is bandwidth and the second one is K3, that is delay. It means EIGRP uses K1 and K3 also. So K1 is 1, it means this is usable in EIGRP. K3 is 1, this is usable in EIGRP. All other are 0, 0. 0. It means the default value of K values are 1, 0, 1, 0, 0. It means K1 is 1, K3 is 1. K1 is bandwidth and K3 is delay. So the bandwidth is totally dependent on bandwidth and delay. By default, we can change these values. We can check the command for changing these values in our practical part. Actually, on Cisco router, this metric is working like that. For example, the K values by default is 1, 0, 1, 0, 0. So the formula for calculating metric is K1 into the bandwidth plus K2 multiply by bandwidth this is divided by 256 minus load. This is add by K3 multiply by delay. The total value of this is multiply by K5 upon, or you can use like this, K5 upon reliability plus K4. This is the actual formula for calculating metric. For example, here I am using this K1 as a 1 and K3 as a 1. So this term is 1, K2 is 0, so this whole term is becomes 0 because this is multiplied by 0, so this whole term becomes 0. K3 is 1, so this value is here. K5 is 0, so this value is become 0. Now here in this formula, the delay equals the sum of all delays of the links along the path, and the bandwidth is the lowest bandwidth of the links along the path. For example, if we have R1, R2, R3, R4, and this is our network. So the sum of all delay is equal to delay that is used is equal to this delay, and this the sum of all delays are used for this formula. And there is some bandwidth, there is also some bandwidth. The least bandwidth along the path, the least bandwidth is always used for this formula. But overall, you can learn the K values are the metric for Eag Rp, and the by default value is for K values are 10100. The K1 is 1, K2 is 0, K3 is 1, K4 and K5 are 0, 0. And as you know, K1 is for bandwidth, K2 is for load, K3 is for delay, K4 is for reliability, and K5 is for MTU. By default, Eag Rp uses K1 and K3. It means by default Eag Rp uses bandwidth and delay only. Now the best or another feature of Eag Rp, that is unequal load balancing. For example, R2, this is R1, this is R1. These two paths are equal costs. For example, these two parts have equal cost or equal metric. It means R2 sends equal data to this network via both links. It means both links are used for sending the data if both links have equal cost. But in the case this link have least cost and this link have a maximum cost. For example, this link have 1 and this link have 2 as a cost or as a metric. Then the best path is this. The all data is sent via this link or this path. So what is the use of this link? There is no use of this link. So Eigrp comes with a concept that is unequal cost load balancing. In this concept, we can send data when two links have different metrics or cost. For this, we using a variable that is variance. variance is used for unequal cost load balancing in Eigrp. By default, its value is 1. For example, let's take this is R1, this is R2, this is R3. Here is a network. This path have a cost, for example, 10, and this path have cost or metric like 15. Now the variance is 1. In this condition, this path is become successor in case of Eigrp. So this successor, by default, this successor is multiplied by variance and it calculate the feasible distance, and this feasible distance go into routing table. And the process is like this. If any other route that have minimum or less feasible distance or less metric by this FD, that all route have include in routing table. For example, in this case, the successor's cost is 10, it is multiplied by 1, it becomes 10. So the FD is 10, feasible distance is 10. This goes to routing table, and then routing table checks any other path is available or not, that path having less metric than FD. For example, if there is another path that have less metric than this 10, this path also includes in routing table. So we play with this value. Now we can change this variable or this variance. We change this variance by 2. Now the successor's metric is 10, variance is 2. Now FD becomes 20. This 20 goes to routing table. Now routing table checks any other path is available or not that having the matrix less than 20. So now the second path metric is 15. So this path is also included in routing table, and the data sent via these both links. We can change variance by 3 also. We can, if we have here the cost of this is 22, and if we use 2 as a variance, then the 20 becomes, this multiply becomes 20. So routing table checks any other path available here that having less matrix than 20. There is no path because this path having 22 as a matrix, so we use 3 here as a variance. So 10 into 3 becomes 30. Now this path that matrix is 22 also includes in routing table, and data will send via both links. This is variance, or by the variance we can use both links that having different metrics. This is unequal load cost balancing. Unequal cost load balancing, that is very useful thing available in Eigrp only. This is all about the theory part of the Eigrp. Now we will configure the Eigrp. We will change we will check the commands for Eigrp. We will change the hello timer command, hold timer command, that is by default hello is 5 seconds, and hold is 15 seconds by default, and all other commands. So now we start the practical part.